This is the Monster 6502, a project to create a working transistor-scale replica of the famous MOS 6502 microprocessor.
The MOS 6502 and its family can be found at the heart of many of the quintessential home computers of the 1980s. Computers like the Apple II, Atari 800, Commodore 64, and even gaming systems such as the Atari 2600 and the Nintendo Entertainment System.
We began this project in 2015, building upon the reverse engineering efforts of the Visual 6502 project. Designing the circuit was a 6-month project, and we demonstrated the first version of it at the 2016 Bay Area Maker Faire.
Since then, we've finished the process of getting it fully up and running, validated and characterized.
And that's no small feat. The Monster 6502 has over 4,000 components mounted to a single circuit board, including over 3,000 transistors that correspond one-to-one to the transistors on the original 6502.
Besides these, the Monster 6502 features over 150 LEDs. These color-coded LEDs light up to show various internal states of the processor, the flow of data, clock cycles, and the instruction being executed. While the Monster 6502 has the same capabilities of the original 6502, it runs a lot slower, topping out at a lightning-fast clock rate of 60 kHz, 1/15 the speed of the original.
But not bad considering that it's a scale model at 7,000 times original size.
It's important to keep in mind that the 6502 is just the CPU of the computers that it powered. We needed to build a computer around it, one that could interface with our keyboard and monitor, but also isn't bothered by the Monster's relatively slow clock rate.
We set out to build a modern computer true to the classic ideals of 1980s computing, combining influences of the Apple II, Commodore 64, and the CIM 1.
Plugging the Monster into the CPU socket allows us to connect to a keyboard and monitor, generate sound, debug programs, and peek and poke the memory.
We are currently working on the second revision of the Monster 6502.
This new version includes some design changes to correct issues that we found when bringing up the first version, but also adds more than 100 new LEDs to further illustrate how instructions are being executed.
If you'd like to see the new version in progress, please come visit us at the 2017 Bay Area Maker Faire.